get the any problem solution, maybe using the, maybe I'm finding the median, mode, etc., by using the method of graphical. So one can able to get the answers also using graphs. Okay, and we are discussing, I think, one two problem based on that, and then we have stopped, right? But there were a little bit query related to like problem when we have a data in between. Okay, so let's just take the recap of that last time problem. So if you just look at the same problem, here, I hope everybody have the problem with them. And if I just look this problem, so I'm interested to get the area, number of students, the marks between 45 and 55, right? That is my questions. I'm interested on this question. Okay, so how to get this particular values? Okay, so see, there is two ways of doing this calculation. One will be either you use less than type graph, or you can use more than type graph. Both will lead to the same answer. Okay, both will lead to the same answer. So I'm just taking first less than type. So using less than type, CF, how to get the second part answer. Okay, so just tell me the values, how many students getting marks between 45 and 55. Okay, so that means I'm interested to get the number of students less than 45. So less than 45 may, what was, how many students were getting at that time? Yes, anyone can tell me that value? So less than 45 marks, what could be there? How many frequencies are there? Can anyone tell me? It is approximated to,
83 or 84, sir.
sorry,
83, 84 something.
yeah, so I can take approximate 83. Similarly, less than 55, approximate 55 means somewhere here.
97.
Yeah, it's 97. Means I'm just considering approximate as per given my respondent. Now, if I take the difference of 97 minus 83, I may lead to the output, which is, I think, is it 14?
Yes, sir.
Yeah. This is using the less than type. One can use greater than equal to type CF and get second answer. How could be? See, if I'm subtracting 45, can you see a 45? And if I draw this line, means just tell me this particular value. What could be that value? At this point, what could be particular values? So greater than 45, what could be the answer? And greater than equal to 60, what could be the answer? So I think greater than equal to 60, we are getting last time. If you just do it, is it 2 or 1? Let me know. Just draw it and let me know these two values, because that is the important. So greater than 45 means you have to draw, this is 45, and this graph will be greater than. So here it will be the point. Just draw one vertical line here. Draw horizontal line. Is it approximate 13, 15, 14? What could be that? Around 15 or 14? Yes, anyone?
So 14.
15, approximate 15.
Yes, sir. 14, 15.
Okay, so let's take 15. What about the one greater than equal to 60? Sorry, 55. This is 55. 55 पे कितना आता है approximate?
2 or 3.
Sorry,
3, sir.
3. Okay. So again, if you take the difference here, then it turns out to be 15 minus 3, which is approximate 12. So see, you may get the answer approximate same. I think this was around 82, maybe according to my data. So you can take approximate 82. This will be 82. Okay. Or could be 82, or maybe this could be approximate 98. So if you just do that, or you can take this will be around 15, or it will be 2. So this become approximated to maybe near to the 13. And this is also approximated to 2. So it would be again 13. Means you may get the answer approximated using this, whether you can use greater than sign or greater than type, or you can use less than type. Okay. But for this, you must check for the accuracy of the data. Means while plotting the data, you should always take all measurements accurately. Then only you may get the answer will be the same. Otherwise, your maybe answers may be vary, but it will be very close. Okay. So this was a little bit we have doubt in the last class. I hope now it is clear. Yes. Any
No,
question?
Yes, sir.
Yes. Anyone? Any question related to this one? Graphs.
sir 97 minus 83 थोड़ी ना आएगा उधर.
मतलब you just change ना according to that. I have just changed above.
हाँ 15 आ जाएगा ना उधर.
Just change. This is going to be 4. Means I'm just trying to managing that, and based on that you can get the answer. So approximate you will be get 30. So as I told you, now you have to make the graph will be like accurately. Then only you may get the same output. Otherwise, there can be little bit discrepancy between these answers. Okay. Okay. Any other question related to this problem? So whenever we have like draw this, so what you have to do, you do it manually, right? You find out manually these values. Okay. And then based on that value, you can locate that answer. So I think we have already seen that examples. Let's move to the next one. Let's move to the next one. Next one is your mode. Next one is your mode. Okay. So I'll try to finish in this session the concepts of mode. Okay. So mode is basically it's a most occurring number, most frequently number in the data set. So whenever we have a data, you need to search that value which is occurring more number of time. It's occurring more number of time. Okay. So that is called basically mode. But what is an applications of mode? Where we apply this, like we have seen for the median, mean, right? But where we can apply the concepts of mode, and where it is there is a requirement of the mode. Okay. So first, what is the mode? Mode is the value of the variable which is occurring most frequently in the data set. That means which is occurring more number of time. That is in the case of when we have a simple raw data. But what happens if you have frequency data? Then highest frequency based on that, whatever the value of x you will be get, that is become mode. Okay. So we will see while solving the example how we calculate the mode. But what is an application of mode? How it is work? So if you just look at the few examples, so I have given only 3 examples here. Average size of shoes. Generally, size of shoes sold in the market is 7. So generally, if you while when you do the shopping like in Mantra, Amazon, and Flipkart, you may we have seen that generally the size of the shoes is availability of that shoes will be up 7, approximate 7. Maybe it may be, I can say, uh, but generally it is 7, because of everybody knows that the number size of 6, that size of shoes which is fixed in particular person who is purchasing is approximate 7. That's why the company knows that we have to manufacture the size of the particular shoes with approximate 7. It will depends on like US and UK. According to that, they are manufacturing. Similarly, average height of Indian male is approximate 5 feet 8 inch, right? So now you can understand this average height means you maybe also visualize sometime like the height of that person is always 5 feet 8 inch. So just a minute, just a minute.
Maya cho con thằng cái cái ya về. Yo Cái tao gọi là vào đây. Beli con. To call me mẹ.
Yes, students, can you hear me?
Yes, sir.
Yeah. So what I was talking, like when you see the height of the Indian people, you may find that the on an average, when you calculate their average height, it is approximated to 5 point, I can say 5 inch, 5 feet and 8 inch. Means I can say approximate 150 centimeter. If I talk about in centimeters, it will be approximated to 152 or 56 ke aspas. Approximate. Okay. That means I will say, looking at this criteria, everybody can understand what type of t-shirt should be manufactured in the market, what type of pant will be, or type of I can say different types of things can be manufactured by companies, looking as a mode value of an Indian height. Getting my point? So how these modes are very commonly used in the market, or maybe manufacturing companies. Okay. Similarly, when we give the example of political parties, generally you may see that the highest vote, right? We have let's say BJP, Congress, and so on. We have parties. So generally, highest votes will be who is going to be winner in the political party, right? So these are the few applications where the person can be use the concepts of mode. Are you getting my point? Have you understood where this
Yes, sir.
mode can be applied? It that is the again I'm repeating here. These all concepts of applications are important. Otherwise, doing all calculation and everything will be quite simple. Nothing is there. But you must understand what are the applications, how it is used in real life situations. Okay? Yes, Geeta Patel, can you mute yourself? Geeta Patel, can you hear me? Okay, so we will see now. Uh, first one is basically mode for mode for raw data, okay, or ungrouped frequency distribution. How this can be used? Okay, so for raw data, as I mentioned, this can be obtained by inspection method or in the large values of mode converted to the data into ungrouped frequency distribution. There are two ways. There are two ways. One, if you have very large data, you find out that particular observation repeating how many times. So 10 is repeating 20 times, 12 is repeating 15 times, 15 is repeating 16 times, like that. Means you can convert the data into frequency distribution table as we have seen in the unit 1. Okay. Then one can get the mode from that particular table. But if the data is small, you can just search how many times it is repeating. Okay, that is very simple. Similarly, when you have ungrouped data, the mode can be obtained again, same concept using maximum frequency. So wherever the maximum frequency is there, based on that, you may get the values of mode. So this is just theory part. You can just understand how it works. So when you do the problem, you can become understand. Now, if you look at the problem number 1, 41, 38, 58, 41, 35. So you may see here 41 is repeating thrice. Can you understand? And 38, 58, they are repeating once. So I can say that my 41 by inspection method. This is called as by inspection method. Inspection method, we are checking that. We are checking that. Okay. So since 41, since you can just write down this data first. Huh? We are interested to solve the problem based on the mode. Since since 41 occurs maximum number of, oh, just a minute, I'm just again I think it's hanged, so I'll start once again. You can see